Hello, sixth graders. So today we are going to specifically be looking at tables and graphs and how those relate to equations. So the first thing we need to remember is that time is always independent. It does not rely on anything else. Time is independent. Okay, and we have talked about on coordinate plane, that is the x. So independent x. So if we are looking at a graph, a table, so something like this is the order. The x is always going to be on top and the y is going to be on bottom. They could use different words, but x goes here, y goes here. Now, when you have a vertical table like this, so on this one you notice they use hours and money. So it doesn't matter. This is still technically our x. This is still our y. So, and if you notice, hours is time. So hours is time, it is on the x, so it is correct. And then if we are looking at this coordinate plane over here, okay, on this one, we have our x here on the bottom and our y here. And again, time is on the x-axis. So that is where that comes from. All right, the next thing that we need to take note, if the graph, so a graph like the coordinate plane, if a line goes through the origin, okay, and we know the origin is at 0, 0. So let's look at this graph right here. So my line that is drawn goes through the origin. So that means it goes through that dot. So that means if I was to make a table, my first two numbers would be 0, 0. And if I had that, that means that my 0, 0 would be here. And then this next one is 5, 6. Okay. But the only way to have start at a 0 and get to another 0 is through multiplying or dividing. So that is a good trick to remember. If you are looking at a graph and it goes through the origin, it is going to be multiplying or dividing. So if you had answer choices that had adding and subtracting, those would be easy Joe Schmoes. Okay, and then here we just have good vocabulary words for add, subtract, multiply, divide, and equals. I want you to take a second. If you need to, you can pause. And I want you to look through these, and if there is a word that you were surprised meant add, then you can put a star next to it. So if you're like, oh, I totally forgot that combined means to add, go ahead and put a star next to that. Or if you don't know what quotient was, and that meant to divide, you can put a star next to that one. So if you need to pause and do that, go ahead. All right, let's go ahead. Excuse me. Let's go to the inside. So number one, Ms. Talamontes gave extra credit, excuse me, on the last test to all students who came prepared to class that day and brought a can for the canned food drive. The table shows the total points based on the student's test score. So which equation could be used to find P, the total points depending on the student's test score? So we have the math equation and we need to find our match. So we are going to look at this table and we are going to practice finding the rule. These are the options. So A, we just talked about a number next to a letter. What does that mean to do? It means to multiply. So this is 4 times S. Okay, B is subtracting, C is subtracting, and D is adding. So we need to decide by looking at this table over here, what is my rule? So how do I get from 91 to 95? How do I get from 86 to 90? So I'm not multiplying by 4 because that would be way big, so that's definitely not it. I'm not subtracting because I'm not going down. So plus 4, let's see, 91 plus 4 is 95. And then I also like to check the last row. 80 plus 4 is 84. So both of those are correct. So my rule is plus 4 So I can check and say, okay, which one has +4? D is my only answer. Okay, and the next thing I want to talk about before we move on is that they used P and S. So yesterday we talked about X and Y, and on the front we talked about a vertical table that this is my X and this is my Y. So we can still use that same thought process here. So this technically is still my X and this technically is still my Y, but they use S for score and P for points. So they are saying that you are going to take your S, which is this row, you're going to add 4, which is what we did, and it's going to equal your P, which is your Y here. Okay, so that is, again, my answer. And we can't forget about this question right here. It says, which of the variables in the equation above is the independent? So we just talked about on the front as well. If you need to flip to the front, what does independent mean? Independent is X. So that's another reason why we labeled this. So is score or points independent? Score, because score is my X. All right, number 2. A carpenter charges $720 for 18 hours of work. She charges the same amount of money for each hour. So it doesn't matter how many hours, she's going to get paid the same amount. Which table shows the relationship between the amount of time the carpenter works and the amount of money she charges? So for 18 hours, she is going to make $720. So I'm going to write that. And before I do that, I also realized that hours is going to go first. So I'm going to write my hours first. So 18 hours equals $720. So just knowing that, I'm going to look at my tables and see if I have any easy Joe Schmoes. And I do. If you look at A, none of these are big enough. None of those match 18 on this side. So I'm going to skip it for right now. Same for this one. I don't have any 18s. But if I look at B, this one has 720, but it says for 19 hours. So that is really supposed to be an 18. So B is out. And then D over here says every hour is $720. So on this one, it doesn't matter how long the carpenter works, he's going to get paid the same amount of money. And we're definitely not going to work more, even though we're getting paid the same amount. So that is definitely a Joe in this situation. Okay? So now I am back between A and C. So the way you could go about this is you could say, okay, how do I get from 18 to 720? And then find your match. Or we can use this kind of like a ratio. So if I was going to fill this in, my 18 would have to go on this side and my 720 would go here. Same for this one, 18 and 720. Okay, and then I need to figure out an easy jump. How do I get from one of these numbers to 18 or one of these numbers to 18? Something easy. So if I see I can do 6 to 18 by doing times 3. 6 times 3 is 18. That means over here, I would also need to do times 3. So 240 times 3 to get 720. If that's true, that's my answer. So on this one over here, on this one, I found even easier. How do I get from 9 to 18? That's times 2 and times 2. And I would rather multiply by 2 than times 3. So 9 times 2 is 18. So I need to do 225 times 2, and hopefully that equals 720. If it doesn't, it's not my answer. So let me multiply this. That gives me 5. That gives me 450. So that one would not work because I got 450, not 720. So by process of elimination, A is my answer there. All right, number 3. I'm gonna have to zoom out a little bit for this one, okay? The owner of a food cart sells an average of 120 frozen treats per day during the summer. Which graph best shows the relationship between the number of days and the number of frozen treats sold? So we might remember from yesterday, we know per means to multiply. So that means if we were drawing a line, they would all need to go through the origin, and they all do, okay? So we can't get rid of any Joe Schmoes, okay? But we also discussed that time, it's not gonna let me write there. Okay, that time is independent, which is which letter, X or Y? It's not how you spell independent. It is my X. So if I am looking at my X, it needs to have time or a type of time. So is the number of frozen treats time? No, that's food. So A is a joke, just because time is not on my X. B, down here at the bottom, number of days. Is days amount of time? Yes, it is. So I'm going to leave that one alone. C, the number of treats. Again, that is another Joe, because treats is not time. And then D is days as well, okay? So now we're gonna go back up to the problem, and I have to find my two numbers. So 120 frozen treats per day. So in one day, when it says per, that means one. So in one day, this food seller can sell 120 frozen treats. So one day equals 120 treats. Okay? And again, that can be written like a coordinate. So my first dot has to be at 120. So let's go to B and let's see. So if I walk 1 and go up, that dot is right above 100, so that's looking pretty good. D, if I walk 1 and go up, that dot is below 100. So that's definitely not going to be my answer. So B would indeed be the correct answer there. So take your numbers from your problem, the 120 and the 1, and then find your dot. All right? Don't forget, find your rule. Use your vocab. If the line goes through the origin, it's multiplying, and time is always independent.